Okay, this is 5.1 rules for exponents. We're going to leave the graphing behind for a little bit, although I see on Alex that it comes up from time to time in the general review. So when we have a term like 7a to the third power or cubed, we say that the 3 is the exponent or the power. So what that means is that there are 3 a's all multiplied together. That's where the 3 comes from. All an exponent means is repeated multiplication. Notice that the 7 is not to any power, so it just stays 7. And that is the coefficient, as a little review, tells you how many a to the thirds you have. So another example, if we had 5 times t times t times t, there would be 3 t's. So that would be, and they're multiplied, so that's t to the third power, and the 5 again is the coefficient. So when we move on, notice where the multiplication sign is. The multiplication sign here was just between the t's, but now it's between 5 t's. And there are 3 of them all multiplied together. So it's the quantity 5t to the third power. We can also have fractions. P to the third, p divided by 3, and we have 1, 2, 3, 4 of them. So it's the quantity p divided by 3 to the fourth power because we have 4 of them all multiplied together. You can also have quantities. Remember, you treat a quantity as if it were a single number. So the quantity a plus 1 times the quantity a plus 1, there's 2 of them. So it's the quantity a plus 1 to the second power, or squared. One of the first rules for exponents, when you multiply like bases, you add the exponents. So 9 is the base here, 9 is the base here, so they're alike. So we simply add the 5 and the 6. So it would be 9 to the 11th. Another example, x to the third times x to the fourth, like bases. So it's x to the 3 plus 4, x to the 7th. In our third example here, we have y to the second times y to the fourth times y, and there's no power there, so it's always 1 when there's no power. So we're multiplying like bases, so we add the exponents. 2 plus 4 is 6, and 1 more make our 7. Again, with quantities, they're like bases, so we just add the exponents. So it's the quantity x plus 2, 8 and 7 make 15. Okay, in the next example, we have inside the parentheses different powers, but they're all multiplied, so the same rule applies. So we add the c's exponents together, 2 and the 4 make 6. The d exponents together, 3 and the 5 make 8. So those were examples of multiplying like bases where we add the exponents. When we divide the like bases that have exponents, we subtract them. And we always go from the top down. So like bases here of 20, we have 16 minus the 9 is 7. One with a quantity, 7.5 n to the 12th, quantity 7.5 n to the 11th, So 12 minus the 11 going from the top down. We have 7.5n, that quantity, to the first power, which is the same as just 7.5n. So when you multiply like bases with exponents, you add them. When you divide like bases with exponents, you subtract them. The next rule is called the power rule, and it only applies when you have an exponent outside the parentheses and inside. So that parentheses needs to be to the up and to the right. In this case it is. So we have the base is 2 raised to the third power. That quantity, or in other words, that answer, raised to the 7th power. So we multiply these. 3 times the 7 is 21. This one looks more complicated, but they just put a bracket here to keep it separated from the -6 in parentheses, as opposed to just -6 squared. So here then, same rule applies. We multiply the exponents. 5 times the 2 is 10. So it's -6, that quantity, to the 10th power. Again, here another example. Quantity z to the 8th raised to the 8th power is z to the 64th. Now, common mistake here is that you have 9 to the 6th, and outside you have a exponent, but it's going with the 9. It's not going with the parentheses. So this is an addition situation. So it's 9 to the 5 plus 6, 9 to the 11th. So the exponent has to be up and to the right for the power rule to be applied. Okay, the last example here. Where we have a parentheses and we have to do some work inside the parentheses first. So remember our order of operations. Parentheses always comes first. So we clean up the inside first. So that multiplied, so we add the exponents and get 7. Now we apply the power rule because we have one outside and one inside after we've cleaned up the inside. So 7 times the 8 is 56. That's our final answer. So here we have to apply the power rule twice. 4 times the 2 is 8, and 3 times the 3 is 9. Now we're multiplying, just straight multiplication, no parentheses left. So we have 8 plus 9 is 17. And we will continue on with this at 5.2.